Hi everyone, today's lesson is reference angles and trig functions of general angles. Trigonometric functions of general angles. Once you draw the angle, that length from pole, from origin to the point, that distance we call that as r, which is usually using Pythagorean theorem, it will be r equal to square root of x squared plus y squared. It's a lot easier with examples, so I'm going to just jump into the example and explain that to you. So example you need to know how to deal with will be similar to this. The terminal side of theta in standard position contains the point 8, minus 15. Find the exact values of 6 trigonometric functions of theta. Okay, so what happened? They gave you 8, minus 15 as a coordinate, and they are asking you to get all 6 trigonometric functions. What do? Plot that point, 8, minus 15. So 8, you will go right by 8. Let's say somewhere over here. And minus 15, you go down by 15. So your point will be somewhere over here. And that will be 8 here. They will go down by minus 15. 8, since it's a positive, you go right. Minus 15, since it's a minus, you go down. And that's the coordinate, 8 point minus 15. If you graph it, that's gonna be where the point is. And this is your right triangle. Always draw right triangle against the x-axis. Do not draw a triangle like this against the y-axis. Always against the x-axis. Once you draw a triangle like this, right triangle, you should calculate missing length, which is this length. So angle of interest here is, this is the angle, reference angle, always against the x-axis. So you can label that as a theta. So you can label that as opposite here. Longest side is hypotenuse. This is adjacent. You can calculate this missing length, which is hypotenuse, in this problem using Pythagorean theorem. So a squared plus b squared equal to c squared. In this label, a squared plus o squared equal to h squared. So h squared equal to, they have equation here. Hypotenuse square. Hypotenuse square is equal to a squared plus opposite square. So hypotenuse square equal to a square plus o square minus 15 square. So h square is equal to 64 plus 225, and that's gonna be 289 if you add them, and take a square root on both sides. 289, if you use your calculator, I think it becomes 17. Okay, hypotenuse is always positive. Always positive. Then what do they want? They want you to calculate 6 trigonometric functions of theta. So you will need sine theta, cosine theta, tangent theta. So applying so katoa, sine is going to be so O over h minus 15 over 17 is a sine. Cosine ka a over h 8 over 17. Tangent toa o over a minus 15 over 8. So these are the answers, and you have to find reciprocal, which is cosecant theta, secant theta, cotangent theta, which will be reciprocal of this. So flip it, flip this, flip. That will be final answers for this. So you should try this by yourself. And if you get this answer, you got it. Next style of a question you need to know will be something like this. Let theta be an angle in quadrant 3 such that cosine theta equal to minus 4/5. Find exact values of cosecant theta and tangent theta. So how do we deal with this? Quadrant 3. So you should know where that is at. Quadrant 3. Have to find the missing length, which is length of opposite. Exactly same. Hypotenuse square equal to adjacent square plus opposite square. You're using Pythagorean theorem. Hypotenuse is 5 square here equal to adjacent. Please do not forget minus. Parenthesis with minus value. So probably it's better to put parentheses on everything. Opposite square, we are looking for opposite. So 5 squared is 25. Parenthesis minus 4 squared is positive 16. All square. So minus 16, you got 9 equal to all square. Take a square root of 9, take a square root of all. So you will become 3 is equal to opposite. So we calculate the length of opposite as a 3. Be very careful. We went down. Down is minus. What does that mean? You have to attach minus. Then we are ready. So you can get sine, cosine, tangent, all that. They want tangent. So you can get tangent theta. They want cosecant, which is a reciprocal of sine. So I'll get sine theta as well, because they will give us cosecant theta. So applying SOHCAHTOA, sine will be O over H, O over H, O over H. Sine will be O over H, minus 3 over 5. Tangent will be O over A, minus 3 over O, minus 4. Okay, minus minus becomes positive. So tangent theta is 3/4. And cosecant theta is going to be reciprocal of sine. So flip it, 5 over minus 3. So that will be final answer. Cosecant theta, 5 over minus 3. Tangent theta, 3/4. Final answers. So when you deal with this question, one thing you have to be careful is when you go left, it has to be minus. When you go down, it has to be minus. Sweetie! Dogs! Okay, this is a question similar to, nope, that was the same question. Next topic you need to understand is reference angles. So depending on which quadrant you end up with, the way you calculate reference angle could be different. But one thing you have to remember is reference angle is always positive. Reference angle can never be negative. Yeah, it's always positive. And you should know it's always a difference from x-axis. So when your angle is located in the first quadrant, between angle, terminal of the angle and the x-axis, this angle is reference angle, positive. Not this. Always against the x-axis. When your angle is located in the second quadrant, your reference angle should be this angle. Always against the x-axis. Not the angle against the y-axis. That's not reference angle. Same thing, if your angle is located in third quadrant, this should be reference angle. Same thing here, that should be angle reference angle, never against the y-axis. So that's one thing you have to be careful with the reference angle. Let's try to do example. So what if it's asking you to do sketch 330 degree, then find its reference angle. So 330 degree, you go 0 degree here, 90 degree here, 180 degree here, all the way up to here, 270 degree here, all the way up to here to be 360 degree here. So you should know, starting from here, go all the way around here. 330 degrees should be somewhere between 270 and 360. All the way up to here, that will make 330 degree. Again, what is your reference angle? Not this. Always angle the difference angle from x-axis. So this is reference angle. So be very careful. How do you calculate the reference angle? You have to get difference between these two. So you can do 360 minus 330 or 330 minus 360 and just change it to positive. So reference angle for this should be 30 degree. 30 degrees is the answer. Okay. What if we ask you sketch this, then find its reference angle? It's the same question, but we gave you angle as radian. So if you are familiar with the radian, deal with the radian directly. If you're not familiar with the radian, it might be easier for you to just convert to the degree and deal with the angle in degree, then convert back to the radian, because once they give you angle as radian, your final answer should be also radian. So I'm going to show you both ways. If you change this radian to degree, it will be 180 degree over pi. Multiply by that, pi cancels out. 30 degree multiplied by minus 150 degree. So plot minus 150 degrees, start from 0 here, minus 90 degree, minus 180 degree, minus 150 should be somewhere between here, all the way up to here will be minus 150 degree. So again, this angle against the x-axis is a reference angle. So how do you calculate that? This minus this, or this minus this. And just change the answer to positive, because reference angle always has to be positive. So if you minus 180 minus 150, you will end up with minus 30. Reference angle is always positive, so just change it to positive. That is reference angle is 30. You don't want to leave your answer, final answer as 30 degree though. Why? Because we ask you angle in radian. You have to answer in radian. Meaning, with 30 degree, you just convert back to the radian by multiplying by pi over 180 degree. Then it will be pi 6th. Will be your final answer. If you are very familiar with radian, there is another way to calculate that radian reference angle in radian directly. So you should recognize minus 5 pi 6th as angle located here. So if you know minus 5 pi 6 is located here without converting to the degree, then you know all you have to do is minus pi. Then all you have to do is get the difference between these two radians. So if you ask me, how did I know this is minus 5 pi 6 located here, that means you're not familiar with the radian. So probably you want to stick to the previous method. If you do understand this, all you have to do is minus pi minus 5 pi over 6. You will end up with minus pi 6. And change that to positive. Pi over 6 will be your reference angle in radian. So try that. Try this question. There's a one style of the question on your Alex homework I want to point out. That will be something like this. Suppose that theta is an angle in standard position with the terminal side intersects the unicircle. So unicircle gives you radius as 1. So if you plot this minus 21 over 29, so you go left, x value is minus, you go left, you go up because y value is positive. So approximately you can draw triangle minus 21 over 29 up by 20 over 29. Unicircle means you have a circle like this, circle like this here, and this length will be radius of the circle. Unicircle means radius is 1. This is 1. If you apply Pythagorean theorem, a squared plus b squared equal to c squared, you do square, and then take a square root, you will get 1 as hypotenuse. But since they said unicircle, radius will be always 1. Then you can, this is reference angle, so you can apply, this is opposite, hypotenuse, adjacent, and just apply SOHCAHTOA to get those values. Then you will get those answers. So since I haven't talked about unicircle, that's what I mean by unicircle. Even though you did not know this, being unicircle, being radius 1, you still should be able to get Pythagorean theorem, o squared plus a squared, parenthesis, plus, take a square root of it, you should get 1 as a length of hypotenuse anyway. Okay, you should be ready to do Alex assignment number 5. Good luck.